Hi class, and welcome to our part 2 of the R Orientation Lab, Lab 0. For this session, we're going to be exploring the data using a package called dplyr. So over the course of this session, I'm going to introduce dplyr as part of the tidyverse system. We're going to explore some data using 5 functions in the dplyr toolset and request some descriptives of specific variables, and also introduce you to saving an R script file for you to be able to use for your homework assignments or your projects. So, getting started, I wanted to welcome you to the tidyverse. We'll go check out this website, which explains that tidyverse is just a collection of packages, but they're a group of packages that we as data science and psychological sciences would use most often. The one we're going to be talking about today is called dplyr, and it's good to think of it like a set of tools. The 5 main manipulation functions part of the dplyr package are these 5: the mutate, select, filter, summarize, and arrange. So those are the ones we're going to be talking about in this session. Arrange is used to sort variables. Filter is used to select observations. Select is selecting variables according to their names. Mutate for creating or modifying variables. And summarize is gathering up those summary statistics like mean, standard deviation, and like that. So, prep. Anytime you're working with a project or a homework assignment, you're going to want to do a very similar prep setup. Download files and put them in your working folder. Install and load any packages that you're going to be using, and put anything into the environment that you need to work with. So let's go do these things. In RStudio, what I want you to do is start working with building your script. So I'm going to open up a script that I started already for this session. And what I usually do is give myself an idea as to what this is about, like a title. And again, that pound sign is a comment line. So R is not going to try to compute this, it just leaves it alone. So it's just information that I'm giving to myself. You want to do that whenever you're saving a script. Keep up in it or keep notes in it to let you know what you're doing, so that when you go look at it later, you're not like totally lost. A good thing to include in your script is what are your goals for that homework or that project, whatever you're working on. Give yourself a list of goals, because it's easy to go down rabbit trails and get distracted. And if you have them listed there at the top, then you have a good place to go back to. So for us in this session, we are introducing dplyr, where you're going to save your R script, learn some basic dplyr format and tools, look at the data using those tools, and describe information on the data, like our summary statistics. So be sure all updates are in there, and install and load the packages you expect to use. So we're going to need tidyverse and NYC Flights 13. So what I want to do there, for installing and loading the package, as usual, install packages, tidyverse, and I can control enter there to run it. And once I have that command prompt again, I'm ready to load it. So I can go, like I said before, in the quick tools. If you get to the one you want, you can just hit tab and it'll go ahead and load it in for you. And I'm hitting Command Enter, would be Control Enter on a PC system to throw that into R, and it runs in the console. So also we need to do NYC flights 13. Control Command Enter, and library NYC 13. And the reason that I want it there in my script is that now I can just run it from the script. Like if I had a startup that I'm always loading the same packages and using them, then I can just put those in the starter script and be able to have it for later. For this session, I also want to put the data frame called flights into my environment. So data and Command or Control Enter, and that puts it right over there in my environment panel. And this is a good point to save your project script. You can give it any name. I can do a save as. If I go to File, I can do Save As. And script for Lab 0 would be good, right? Alrighty. So let's get started by checking out this flights data set. And this is the same kind of inquiry tools we used before, like View, which will put it all up in there so that I can just go ahead and see what I have there. But also we have the information about it, that it's a lot of observations and 19 variables. Or I can also look for it in the help menu by searching for flights, or calling for it over in by using question mark flights, and that would bring it up as well. So it looks like we have on-time data for all for flights that departed from New York City in 2013. We have 19 variables, a whole lot of observations. There's all of our variables, and here's some information about those variables. But it basically looks like integers, numbers, a few character variables, like carrier is a character variable, tail number, origin, destination. But then most of the rest are numerical or integer, right? When we have so many observations, we need some way to handle that large amount of data, depending on what we're trying to understand or discover about that data. And that's where the deployer comes into usage here. Generally, the structure of deployer functions is going to be the function, open parenthesis, what data are we using, and then what arguments or details need to be included. So our first tool we're going to check out is called Arrange. And I'm going to go back to our PowerPoint so we can check out the Arrange function here. Again, it's used to sort the data based on variable values. So a few things we'll try here is flight with the longest delay, the shortest flight distance, the farthest flight distance, and the fastest flight speed. And again, we're just sorting the data. This would be similar to if you were using multiple sorting variables, like in SPSS, if you use sort cases and you have multiple variables that you're sorting the cases with, or if you were using Excel with a custom sort and using more than one column on your sorting command, that's kind of very similar to what they're doing here with the arrange function. So let's try it out. To arrange by date, we'll put in arrange, the function first, right? Now I need the data. The data is called flights. There we go, comma, and the arguments. So if I'm sorting by date, I would want the year, followed by the month, followed by the day. And I'm going to command or control enter there, and it sorts it and puts the beginning lines there in the console. So I only have the first 10 rows, but the first one was that one on January 1st that left at 5:17 in the morning. Yep, that was the very first flight of that arrangement, that sorting and ascending. So what if we wanted to find out some of these other things about the longest delay for the flights out of New York City? We can arrange by delay. Again, arrange function, open parenthesis, flights, comma, and I want delay. Let's see which one. I have arrival delay and I have departure delay. So out of New York City, I'm probably going to want departure delay. Now think about it. This is sorting ascending, right? And if I want the longest delay, it's going to need to be backwards sorted, right? Sorted descending. So I'm going to run this one. This is ascending, which is command enter. And you see here on, looks like December 7th at 8:40 in the evening, has a -43. That means they left early, which we find out over in this information about the data set. Negative times represent early departures or arrivals. So for the longest delay, I need to descend sort it. No worries. Arrange flights, and now I'm just going to put descend, open parenthesis, departure delay. So when we sort it that way, the top guy was on January 9th at 6:41 in the morning and had a 1,301 minute delay. That's the longest delay on January 9th there. So let's try a few others with arrange. And as you try these, just a heads up that in the notes of the PowerPoint are the answers based on who would be top on that list in your console. So it says that the longest delay departed on January 9th, so you can try it out and see if you sort correctly. So how about the shortest or farthest flight distance? So we would need arrange flights distance. Right there, distance between airports in miles. If we sort just by distance, that means the smallest numbers at the beginning. We get this for the first one. See all those NAs? That means not available. In other words, missing data. It's likely that that flight on 7/27 was canceled. So it doesn't really count as a shortest flight because it never really left. But this next one on January 3rd had the shortest distance to fly. If we want that same thing but now descending, we can do that by putting the descending in front of it. In fact, if you come down to your console area, like where the code is actually running at, and you press an up arrow, it's going to give you the last code you ran. So you can actually go into that code and type in DESC, open parenthesis, and put a parenthesis on the end, closing, because they always go in pairs, and now run it. And it just added that to it. It appended, it modified the code that you just ran in there. So the one that had the longest distance left on January 1st at 8:57 in the morning. Cool. Okay, let's try another one. The fastest flight speed. So this one, we don't have speed as one of our variables in this data set, but we do have the information we need to calculate it, because how fast something is just distance divided by time. We have distance, we have airtime. So what we want there, arrange flights distance divided by air time. So here the top one says January 28th. However, can you see the problem with my code right there? If I'm sorting by speed and I'm looking for the fastest speed, I really need this sorted descending, right? I want the fastest speed at the top. Right now, the plane I have at the top is the one that was the slowest. So I'm going to go back into this code and add descending and add the second closing parenthesis on the end. So it's going to backwards sort it. And I'm going to command return. There we go. The fastest plane left on May 25th at 17:09. Notice that we're not rearranging the actual flight's data frame. It's just kind of temporary, this resorting. Flights is still in the order it started in when we first put it into the environment. If we want to keep this arrangement for later use, we have to name it as an object to put it into the environment. So I'm going to take this, I'm going to just copy paste my code right to there. But I'm going to go in front of it and name it as an object. Let's call it fast. So that's kind of some of the things we talked about on the first day, that I have an object that's assigned by a function, and then here are the arguments to that function. So command enter, and now I have a new item in the environment called fast. And when I drop that down, it's still in the same right there. I want to see it over, I want to view. There we go. I want to see it where I can compare them. There we go. So here, the fastest one is at the very top row on May 25th, whereas in the flights data frame, the original one, it's still the 11517, because that's exactly how it came in. Okie dokie. That's a lot, right? We only got 4 tools to go. Our next tool is filter. Let's go check that one out. So again, that basic framework for the code is the function, and for dplyr tools, you tell it which data it's using and then the arguments. And the filter is used to get a subset of the data based on the values of those variables. So if I want a subset of the data for only the flights that departed in May, how can filter help us with that? Let's start there. So for May, let's say we want filter. Again, start with the function, open parenthesis, flights, month in May. So we know that the months are indicated with the numbers, right? We can see that up in here. We want month, whoops, where is this? There you go. Month is equal to 5 for May. And when we enter this, again, it puts it into that temporary state that I have this set that's all in the month of May. How many flights in the month of May? 28,796. And again, I put like the answers in the notes section of the PowerPoint. So if you want to try it afterwards, you can go see if you get the same numbers. How can we keep this subset of data for future use? Again, we have to name it and put it into the environment with its own name. So I'm going to say, let's call this guy May, is assigned by the filter of flights when the month is equal to, 5. And now I have May over there. And you see how I'm using that equal mark? So that's is equal to. And these logical operators are, you have a whole list of them in your R for Data Science book in 522. I'll switch over to that. Here's our book. And if I go to chapter 5 and 5.2 and scroll down to 2.2, there's a whole section on the logical operators and the list of them. We use those to explain or clarify to R what we're wanting. And that makes it possible for us to ask R for more complex subsets of data. Like how many times in your industry or your field do you need a subset that is specific in many different ways? I need a specific age or gender or origin or time of hire or whatever. So this makes it possible to make a more complex sorting. For example, what if I wanted flights in the summer? So July, August, and September. There's different ways this can be written. I can say filter the flights such that the month equals 7, or that bar means or, the month equals 8, or the month equals 9. Another way of telling R this, filter the flights that month is greater than or equal to 7 and less than or equal to 9. And then a third way, filter the flights that month includes the months 7 through 9. So you want to get into the habit of reading the code, like even if you verbalize it or put it in your own words, because that helps you kind of develop the language. What you're doing here is learning a new language. And when you practice it, both writing it and saying it, it helps you get it integrated easier. So application is the key. Using it and seeing how can I apply this in my industry is where this starts really making its connection for you when we start working with our own data sets. So keep that in mind on all of these tools. Okay, next tool up is called select. And select is used to select variables based on the variable names. So not necessarily the variable value, but the variable name itself. So what if we only wanted specific variables to take a look at? With 19 variables, we're only seeing the first few each time. Maybe the ones we wanted to see were the ones about delay. What we can do there is say select the function, open parenthesis, the data, and then what do we want in there, right? We want, let's see which ones. Depart, delay, whoops, over here. And arrival, delay, is that it? Yep, I can do it like that. So Command Enter, and now I have those two variables as first, being shown. And again, it didn't change my data set at all. It's just showing me those two variables. I could have also written this using some extra arguments. So select flights, if I spell it right, contains delay. I couldn't use a capital letter there because there's no capital delay there. So let's try that one. Yep. So now I have those two. So different ways we can tell R what we're after. And again, in your R for Data Science, whenever you see these little indicators, I'm just letting you know where that information is easily found in your book. A nice functional thing you can use select for is to reorganize the data so that the variables that you want, that you're most interested in, are at the very beginning of the data set. So what we can do is say select flights. Maybe I want origin at the beginning, and then everything else can come. Yeah, and everything is going to put that extra empty parenthesis right there, and that's okay. So I'm going to Command Enter there, and you see I have all of the observations, the 19 variables, but now origin is up at the beginning. Now again, this did not change the flights. It still starts with year. If I want to keep this, I have to name that object with a new name. So I can do a copy paste, grab that code, but now give it a name. How about origin? Now when we run this one, we have a new item in the environment, a new object, and its first variable, because we put it first, is origin. So we have origin first, and then everything else follows. Okay, so here's one that's really fun. Mutate. It's used to create or modify variables. So it's similar to the compute variable in SPSS, or when you create a new variable using a function, or a new column using a function of the other columns in Excel. And let's see what we'll need to do to compute a new variable or column for flight speed. We'd already played with this one before, in that speed is just distance divided by time. So let's make a new variable defined by distance divided by time. So mutate, open parenthesis, flights. And I want to name a new column called speed, and it's going to be defined by distance divided by airtime. All right, Command Enter. Cool. So look at this. Now we have 20 variables, right? And we had to, part of the arguments here is to name a new column. That's different than what we've been doing before. We have 20 variables because speed is the one tacked on to the end right there. Can't see them because it's so huge. And this did not change the flights data set. It's still only got 19 variables. So if we want the new variable added to a data frame, we have to add a new thing into the environment, or we have to overwrite the flights data frame. So we're going to create a new data frame. Again, we can just go ahead and copy that if we want, or type it in. Either way is good. But we're going to give it a new thing. Let's call this one speed. Is assigned by the mutation of flights such that we're adding speed as a variable. Yeah, so work on reading through the code. Command Enter. Now we got a new item over here in the environment called speed, and it has 20 variables. Okay. Summarize. Summarize gives us that summary information that we're used to getting out of statistical programs, like the mean, median, standard deviation, variance, stuff like that. So we're going to play with this one and start with what is the average delay of flights. For example, we're going to just read through this one. So summarize flights. I have to give it a name and tell it what function is going to apply to this new item, average delay. Also notice this piece right here. So we had to tell R to ignore missing values. If it's a non-available, just remove it is true, is what we're going there. Summarize the data set flights such that average delay is equal to the mean of departure delay, and ignore missing variables or missing values. Yep. This is similar to mutate because this new column is only in temporary memory. It doesn't change flights at all. I'm gonna run this. The average delay across the whole data set is 12.6 minutes. But typically, we're wanting summary information in groups. I don't want just the average delay over the whole year. I would like to know the average delay per month. And this is very typical of the things we're looking at in our data sets. Maybe we want to group by gender orientation or religious or political affiliation, or what clinics or therapists the clients are seeing, to look at if there's differences between those groups in means. So we're going to make it a little more complicated here in the summarize function using group by, and also wanted to introduce you to piping commands. Group by tells R to apply the summary request to grouped data. And you can get to information about that in your R for Data Science at 5.6. But again, say we want the overall delay per month over the year, not just the whole year. What we can do is first assign a new item. I'm going to call it monthly, such that we're grouping the function group by the date of flights by year and month. So I'll run that one first, Command Enter. And now I have this new item called monthly. And all it did was group those observations by month. Now I'm going to run the summarize function. Summarize monthly, right? The new item in the environment, such that I have a new column in temporary memory called month delay, which equals the mean of departure delay. Ignore the missing values. So just take it one piece at a time when you're reading through code. So we'll run that. And now we have a list of all the delays per month. And again, I put the answer to the by month delay in the notes on the PowerPoint if you try it later and you want to make sure you got them right. So one thing to notice here is it took 2 steps. We had to set up an item, an object in the environment first, and then do the summary on that new object in the environment. The pipe tool is a way to get around that, and it actually helps us read through the code easier. So we can string together multiple requests if we're working on the same data frame. It does have a different format, so this is going to be a different kind of way of reading through it that we haven't done before. We're going to start with the data, tell R the data first, then our piping indicator, followed by the function and the arguments. So if we take that prior request that we already used for the monthly average delay, using the piping, it would look like this. I want the data set flights, then group it by year and month, then summarize the average monthly delay, which is the mean of departure delay, ignore the missing values. So let's try that. I'm just gonna, it can be anywhere in here, and I'm gonna Command Enter. Oh, it did it again. I'm like, where'd it go? It's the same thing we had before. So there's our coding that we ran, and here's that same set of average monthly delay, but it only took one very long stacked step instead of 2 steps. We didn't need that monthly item in the environment to be able to run that. Okay, let's try it a little trickier. Sometimes we want more than the mean, right? Oftentimes we want more than the mean. You know, there's standard deviation, there's variance, there's count, there's all kinds of stuff we ask for from the data. So with piping, we can just string all those together. Like, let's take all of this, I'm going to just copy and come down here. What else do we want? Let's say we want the average monthly delay would be the mean, and then let's say I also wanted to summarize the standard deviation monthly delay. I'm just making up names there. You can call it what you want, just make sure they don't have spaces. SD of departure delay and comma, ignore the missing values. And let's say if I want the count, I'm going to want it up front. Let's do n yeah, I'll call it count equals in open parenthesis, and you can just leave it empty on the parentheses because we're just counting how many are there all together. You see that X? That's a good thing to see. when to note, it's not a good thing all the time. So when you see an X like that, our studio is letting us know something's not quite right here. And you see when I hang on it, expected a comma after our expression. You know what? It's right. I needed a comma there. So that's kind of helpful. Now I'm ready to run this. So Command Enter, and I have a cute little table in groups by year and month that are the count, how many in each month, the delay, and the standard deviation of the delay. See that? So that's cool. Okay, and I gave you one other on the PowerPoint. That's summarize. This is the pipe function. Let's try this one. Using flights data frame, group by year and month, call for summary statistics and the standard deviation, that much we have so far. Then how show months with average delays greater than 15 minutes. So we can stack on more stuff here. Let's take this one we just built. And after the summarize, with the piping, the cheat shortcut for it is Shift Command M, like that. So I can say flights, then group by year and month, then summarize the count, the average mean of departure delay, the standard deviation of departure delay. Then I wanted to filter the average monthly delay that is greater than 15. Yep, let's try that. Yep, there we go. So 3 months, June, July, and December had delays greater than, average delays greater than 15 minutes. So it takes a little bit to work it through. Take your time. It is a learning curve and a half, and you're learning something new every day. Let's see. If we want to keep this summary, we have to give it a name. So I'll just go ahead and add to this more than 15 assigned by this whole thing. And I can run that. And now I have more than 15. There's 3 observations of 5 variables. Cool. Okie dokie, guys. Let's see what we got left on here. So what did we do today? We introduced the dplyr package, which is part of the tidyverse, created your first starter script, explored the data frame using the dplyr tools, and introduced a couple of handy tools, the group by function and the pipe operator, and practice reading code. You can find this material in your R for Data Science book, mostly in Chapter 5.